The first presentation, Successful Composites Development and Upcoming Developments, is given by Joe Stilwell. Joe's a PE, and he's a fabrication engineer with the MaineDOT. He's also taken on some new responsibilities in terms of directing multimodal work, which I just learned of. So we don't have your full title here, Joe, sorry, but I'll give a nod to it without the actual name. He's a mechanical engineering graduate from Maine with a PE in civil engineering. So right there, you know he's suspect, but he's a good guy, don't worry. His background at the MaineDOT is in bridge construction, structural design, and project management. In his current position, he oversees the construction of all prefabricated structures and components for the Maine Department of Transportation. Recently, he oversaw the fabrication of the first of its kind composite tub girder bridge. Joe's a steering committee member of AASHTO's National Transportation Product Evaluation Program. He's chair of the Composite Concrete Reinforcement NTPEP audit, where he developed a work plan for auditing and sampling GFRP reinforcement. He sits on the IACME INC group and is also involved in the Standing Committee on Bridges T6 committee, which is AASHTO's FRP Composites committee. So he's very active in industry, a supporter of the things we do. I would like to welcome him up here now to give his presentation. Joe.
So this is going to be a little more grounded than all the other high level theoretical stuff. So this is practical real world applications that you could take away from today and implement them in your locations tomorrow. So MaineDOT leading the way. MaineDOT is probably one of the leaders in composites in our infrastructure of any state in the country. And I will say that with a straight face to Florida. So we got the arch bridges, pile, scuppers, GFRP rebar, utility trench plates for the Port of Eastport, the old style Hillman composite beams, wrapping, FRP wrapping of pipe pile, 3D printed precast molding. And of course, everyone has seen the pictures of gristmill over this week. And then there's Twin Bridge. So what I'm going to do is target the things that people haven't heard about much. I'm going to do very limited on structures. Mr. Kennerson is going to go very deep into that. So I'm going to do the bread and butter, practical, cost-effective solutions. So GFRP reinforcement, MaineDOT has been utilizing it for 10 to 12 years now. In the last 5 years, we put down over 2 million linear feet of rebar. Why does it keep jumping on me? Our standard practice, automatic. Right. So, okay, technical difficulties. Standard practice for our projects, and it's still doing automatic on me. Why does it hate me? Of course. You know, it's going to go faster. It knows that I can talk forever. So our standard practice, if it doesn't come back, is to use just straight bar, because in the manufacturing process of GFRP, each individual bar itself is to be specially made. It comes out of the dies and wrapped around a jig. So which makes it really hard in construction if the contractor, say, miscounts a bar, loses a bar, and is still playing on me. Okay, I'm just going to do this the hard way. Right now, because stainless went up through so much money, we're using 1035 Chromex bar. It's cost effective. Our major suppliers, don't go, are Owens Corning out of Concord, New Hampshire, Concord, North Carolina, wow. And then Poltrol, who's out of Thetford Mines, Quebec. They are about 3.5 hours from here across the border. So as far as it comes as a supplier, they're actually a very close supplier to us. It's not like we're bringing rebar from New Hampshire, New York, Massachusetts, Connecticut, that area. They're really close. You good, Aaron? So, should be. Okay. Can you go back one slide? So there are other, MaineDOT's QPL, we do have 2 other suppliers. One's in Toronto, one's in Alberta. Trucking that from Alberta is a little hard to get out here, but There are other manufacturers of this. There are 4 major ones. We're talking millions and millions of linear feet a year out of North Carolina. Tough Bar and MST Bar are a couple million feet a year. So there's lots of capacity out there if other people want to go using GFRP. ACI just codified it into their standards. I believe it's now in the IBC. So this is not a new stuff. This is a mature technology with applicable design codes for both DOT applications and vertical construction. So this can be used by anyone for anywhere at any time. So the next bread and butter thing that we do at MaineDOT is we're doing composite drainage by policy. So why do you use composite drains? Everyone's seen these things, all steel scuppers, rusted, falling apart. And it's a maintenance issue. You get holes in your deck. But if you're putting GFRP in your bridge deck, why would you put a metal scupper back in there where it can corrode and you have a weak point again? So as part of our system, MaineDOT worked with the National Transportation Consortium as a pool-funded study. MaineDOT was the lead. Dale was a chairperson. Mike White was MaineDOT's technical rep. Roberto did all of the testing up here at UMaine. So this is another partnership between that MaineDOT has done with UMaine. It's not just big bridges, other solutions as well. And the goal is to develop the design. And we have two of the trial projects of that time frame. So we're talking 2014, 2015. Time frame, not really that long ago, but in development, it's an eon ago in these type of technologies. So just kind of a chart of, as you can see, how MaineDOT is doing their stuff. 2010, one little experimental project that we did with UMaine, just to kind of proof of concept type. Then we done nothing, bunch of steel scuppers are gray steel. And then as you can see, 2013, still doing some, 2014, 2015, no more steel scuppers. 2016, we did a couple. 2017, they're pretty much all gone. As you can see, over 40 scuppers were put out there, and we had 2 of the standard steel ones. Now going forward, 100% of them are all FRP scuppers with a stainless steel grate on it. Why put galvanized when that can corrode too? So it's stainless steel. Or if when the composite industry can come up with an LRFD designed capable grate, that's allowed too. Task for you, John. But everything else is just kind of minor rehabs for any steel inserts. So if we're just kind of doing, oh, we're not gonna do anything on this bridge, we're just gonna fix a drain. Okay, we'll replace it in kind. It's really a one-off. It's not a policy to do that. So all new construction, all composite scuppers. And from our experience, they've been, once you use a standard size, the cost of them go down. The more you do, the better, of course. So that's why if we try to do a whole bunch of the same ones at all our bridges, we're only talking 15, 20% more than your standard galvanized scupper. But in the lifespan of a bridge, when you're investing in the future, it's insignificant costs. So this kind of pictures of kind of how they evolved and how they can be adapted for every situation. These are the original ones. Look pretty crude. But then as things evolved, this is one of the experimental ones you see. Different colored bar. There's another one flying in there as well. And so the one over there, the brown one, so they can be colored to match any structure. Weathering steel bridge, brown scupper. Concrete bridge, metallized bridge, gray scupper, blends right in. And that one was actually modified from the standard design so they can mount it into the curb. So it's got a little lip on it. You can make them fit any situation for any configuration that you need. So going to some of the structures that we have. We've got 8 of these composite arches technology, then developed by the University of Maine. So we got Edmonds, LaGrange, Caribou, Belfast, got a comma for Bradley, Ellsworth, and there's one in Auburn. So top left is the Caribou connector, I believe it's Caribou. Now LaGrange was an interesting one. It was a staged bridge with a 46-degree skew, 56-degree skew. So that was more of a proof of concept as well. That's why you can see it looks like it's helical in there because it's, let's just say construction of that was an adventure. I assisted when I was out in the field as an inspector on this project. So proof of concept, can do it in any situation. Composite tub girders, the latest and greatest in composite bridge structure technology. You got gristmill, twin bridge, standard tub girder configuration. As Tim hates me to say it, I call it the next beam knockoff. So a pie-shaped girder configuration, very similar in layout to the standard pie-shaped composite precast concrete girders that is used bread and butter everywhere in New England for 50 to 75-foot spans. We got, of course, both Hampton bridges. And maybe we'll have a third one here in the next 3 or so years. Then we've got probably the granddaddy of composite bridges. So we got Union Street here in Bangor. That was the last one we did. If you drove up 295, you drove underneath it. And then the first one, Booth Bay Knickerbocker. So that was when I started with the department 13 years ago this year. That's where I started my first project as an inspector. So been exposed to this thing as a very impressionable age. And that was an interesting concept, and it was a good just showing what you can do with composites. The modern evolution as technology evolved is, in my opinion, a better solution. So we'll go substructure now. FRP piles. Yes, I know I forgot Mariahville. So we have two more recent constructions with FRP piles. One down in Southport, literally in the ocean, and another one up in T3 as a contract mod. As you can see, Southport's been in for a few years. That looks exactly like a concrete pile with all the stuff on it. You never know looking at it if you didn't know what it was and went out and touched it. So you can make them any color. The black one done at Composite Advantage in Dayton, Ohio, went up to T3 for that pier redesign, high flows and ice and everything. So we are expecting that and we have faith that those piles will be able to handle up to ice flow, flood conditions. And they work really well, and it's a solution to get away from the old steel epoxy coated stuff. As you will see here, fusion bonded epoxy on pipe piles is a maintenance nightmare. So bridge over there we used a standard fiberglass mat that was infused with a pigmented epoxy that would cure underwater. So we use divers and we wrap the piles with that, because in the tidal zone, the fusion bonded epoxy on the piles failed. Bridge is in beautiful condition, but you have a substructure element in a tidal water where in the tidal zone, its coating system was falling. So without any attention, you're gonna have a bridge you're gonna have to replace that was built in 1996 on Route 1 in York when everything else was beautiful. So this is kind of some of the rehab stuff. This is a pier wrapping project using the Denso system that you have everything's good except the piles. Painted steel is good, but when paint fails on steel, it's exposed to elements, saltwater environment. And the bottom picture is the York project when it's all said and done. Gray, it looks like a concrete pile. So pipe piles are not the only ones we're looking at. We are also doing a similar but different treatment to H piles. So you got the old H pile, old H trusses sitting in water. We are using a two-part composite shell that kind of wraps around it. It is literally screwed together and then ratchet strapped to hold together for the head pressure of pouring in the concrete, or there's a different one that's actually an H shape that can be filled with an epoxy grout. And it is used as a stay-in-place form. It's never going to rust. It's not structural because we caught the piles before they were in too bad a condition. But it's also got the holding the concrete up so it can handle all the abrasion. cheap, effective solution to retrofit a substructure that will preserve this bridge for another 30 to 50 years until you have to replace it due to other elements. You're not having premature deterioration of the supports. So I would be remiss if I didn't give people credit where credit is due. MaineDOT is not the only group doing these type of innovations. So as part of the work that I had been doing as a fabrication engineer, I was in and out of Kenway Composites in Augusta's facility a number of times. They do our bridge, they do 90% of our bridge scuppers. When I was down there, I saw these other cool and innovative products that other people were doing. So I figured I'd kind of share it out there. This is not a bridge thing. You can use this on many different things. So rail platforms. They replaced all the rail platforms in the light rail line for Massachusetts Transit Authority. Army Corps has gone full hog onto composite as well. They are replacing all the wicket gates on 2 of their locks there. It's like 40 locks. These things are 13 and 18 feet long by 5 foot wide. They are monsters. So there is a composite solution to a lot of problems. You just have to think outside the box, and we may not have done it, but other people are adopting their solutions. I really like these rail platforms. These are all concrete things. They pulled them out. This was a weekend shutdown. They pulled out all the new stuff and put in the new rail platforms all in a weekend. So, and this all done here in Maine. Yeah, I'm going. See, I know where I'm at. And this is North Carolina. A fully compositely reinforced bulb tee. Carbon fiber pre-stretching strand, carbon and glass reinforcement. There's no steel in that girder. This is part of their Harker's Island project. So if you want to get more information on it, it's Google Harker's Island project. It's got a great webpage. My counterpart down there, Cabell Garby, sent me these pictures, and I thought they were really cool and be good to share with others. I'd love to do one of these in Maine. So upcoming developments. Yeah, Roberto doesn't know I have these up here. So last year, we did some 3D printed forms, proof of concept. 6 precast ballast retainers, 2% cross slope with battered slides. Not complicated geometry, but complex enough that standard wooden forms may not have worked. So they went nuts and used carbon fiber to 3D print these things. 96 hours, they're not light. They're 6,300 pounds if I remember correctly. But honestly, they work beautifully. That's the reinforcement in the precast shop, dumping concrete in there, using like any traditional form. There is a piece of it downstairs outside, that black thing. That is a piece of this form. And these were put in Railroad Sheridan. If you look at those, you would never know those were done with a 3D printed mold looking at them if you hadn't seen them come out of there. They're absolutely beautiful. And I think this is a technology that we could evolve to in the future as prices go down and understanding of the system goes up. I know there's a new big 3D printer here. And then the big issue with the composites, not being able to bend it. Cody and Roberto and crew are working on field bendable rebar. So you can actually bend the mild reinforcement again if you need to remake a material. Soon, when everything goes well here and all the research, this could overcome the limiting values of standard composite reinforcement. See, they bent it, so it's structurally worked. There's a lot of environmental stuff to go. So this is still proof of concept, really phase. I know Cody's going to do a lot more deeper, but this has got some serious potential.